Hello, and welcome to episode 2 of our AP Statistics review sessions. We are tackling in this video the Chapter 1 study guide. Chapter 1 is from way back in end of August, early September, and there we were talking about graphs for the most part. How do you make a graph, but more importantly, how do you analyze it and how do you use it to do other things? To my kids in 2020, you guys are aware you have that reduced 2-question free response AP test this year. My prediction, kind of a bold prediction here, but I believe that one of the two problems at least will be strongly tied to some sort of graph that you have to analyze. A couple of reasons I think that. First of all, there's a lot of really good stuff you can do with statistics that begins with analyzing a graph. So it's just good in general. And it's a topic that's on the AP test quite a bit. A second, more logistical reason I think this is because a problem centered around a picture that they create on the spot for you means it's going to be a lot harder to cheat or to look up the answer and just know what it's going to be. So given the format of the test, I feel pretty strongly that one of your problems is going to be centered around interpreting some picture with data that they give to you. I could totally be wrong with that. So my future kids watching this video, you guys can look at this, judge me for it later. But I do think, if I had to put money on it, that there is going to be a big graphing problem on this year's test. So let's get to it. First page is all vocab. Make sure you guys fill this out. Your job is to read the pages I mentioned, the exact same thing we did last chapter. You fill this out yourself, then tackle these problems on your own before you hear me explain them. So, first multiple choice question is asking us to make a stem plot or stem and leaf plot. And stem and leaf plots, you guys recall, are these guys right here. You make a little T-chart usually, or it could be like a 2-column thing where there's like rows going each way. Your stems, though, are going to take all but the last digit of your number. So, for example, my first number is 145. I would have a stem of 14. And then I would have a 5 over here, and then it would say somewhere on the side there'd be a key that meant 145. If you look at your numbers, my smallest number is a 96. So I would have a 9, or for being consistent in terms of number of digits, 09 would be good. So I'd have 96, which would look like this. There's nothing in the 10s. My next smallest number after 96 is going to be 110, but you still have to put them in here. If I was making this multiple choice question, I would make sure that I had a choice that didn't have 10 on it. But you need it even if there's no entries. Then it would go to 11, then 12, then 13, and I'm out of space right there. But the correct answer on this first problem, the stems that you should use, is going to be answer B. So making a stem and leaf plot is our first question. So let's move on to our second question, which the other piece to this chapter that they kind of snuck in there, in addition to just graphs, which was most of the chapter, is the idea of standard deviation. Hopefully by this point of the year, standard deviation feels like an old friend. We've been using it for so long, but this was back when we first learned how to interpret standard deviation. And you guys should remember standard deviation, the interpretation or the script, is that it is your typical distance from the mean. So if the standard deviation of weights of infants is 10.2 and the mean is 128, that's saying that typically the weight of a given randomly selected baby is going to be about 10.2 away from 128. Some will obviously be closer to 128, some will be farther, but they will average out to about 10.2 away on average. That is going to be choice D for this problem. So second multiple choice, answer D. Third problem is a pretty important part of this chapter. For future kids, this ties in as well with chapter 11 with our chi-squared distribution. For this year, 2020, that will not be assessed on the AP test. So that's not as big of a thing. Your main job, if you're 2020, is looking at one of these tables and turning everything to percents. You need to turn them to percentages, especially when your groups are different sizes. If you take the time to count these out, or add them up or whatever, there's 250 total. 140 of them are females, 110 are males. So comparing raw numbers is no good. You need to turn them into percentages to compare them appropriately. And then in terms of which way do you divide them? Like, do you divide them going like through education, through environment, or do you divide them female, male? The variable most likely to be explanatory is what you make for your group. So does it make more sense for education and environment to be explanatory or for female male to be explanatory? And female male makes the most sense. So when I'm making my percentages, I'm going to go this way with it and put these guys out of 140. Then I'll do the same thing with my males as well. Totally messed up my picture right here. So I'm going to go ahead and erase that, give myself a little space. I'm not going to write all of these out, but if you divide them out of 140, the ones I am going to put down, they talk about the environment. So I'm going to put those down. This is a 0.22. That is just terrible handwriting. That is 33 out of 140. And the one below it, 29 out of 110, is a 0.26. And then for health, the last one I'm going to write down because it applies to one of the choices is 0.36 right here for women. And I can fill out more, but you guys get the idea. You just write out all your little decimals. So we got to look through these choices and see which one is supported by my data. A says most of the females who chose a health organization, health ended up being the most popular choice, would have chosen an environmental organization as their second choice had they been asked. So this is a misleading question. Health is most popular, environment is second most popular, but that doesn't automatically mean that these people, the health people, would choose environment if they couldn't choose health. These people could also feel very strongly about international aid or whatever else. So you cannot assume what they're saying in A to be true. The second popular choice doesn't mean it was the health people's second choice. B says there is no association between gender and choice of organization. If that were true, my percents for male and female in the same thing would be identical. So I'd have 22% environment here, 22% here, because no association means knowing explanatory doesn't tell you anything about response. But if I know somebody is female in this problem, I know they're actually a little more likely to care about, little less likely to care about the environment, a little more likely for health and other things that I didn't write down on here. So there is an association because your percentages do not match up. C, the proportion of males who said they would contribute to an environmental organization was higher than the proportion of females, 26 versus 22. That is the correct answer out of our choices right there. You needed to make them percentages to do that. So the third problem is C. D is incorrect. That could be under other for religious organizations. And the marginal distribution, last thing on this one, marginal is where you only look at one variable at a time. They did the marginal with the 140 and 110. That's for gender, 140 females, 110 males. They didn't say anything about the organizations. So for organization, you would have all the totals going down this way, like the 42, etc., etc. So that is our third problem. I don't know why that D is sticking around on my screen. I'll erase that. Okay, so on to my fourth question here. We are looking at a histogram, and we're being asked to figure out where the third quartile is. So the third quartile is the 75th percentile. It's the 3/4 mark. If you take your list, you break it in half. That's the second quartile or the median. And then if you take, I don't know which way is upper and lower on your screen, but whatever, the upper half right here, and find the middle of that, that is going to be your third quartile. So to write that out, if I have 50 numbers, I would have a big old list of 50 numbers right here. This would be number 25 right there. This would be number 26 right here. And then it would go all the way up to 50. So the median, or Q2, would fall right there. I would do that again on my upper half, and the number dead middle between 26 and 50 is 38. And you can count that out to see, oh yeah, that's plus 12 and plus 12. It balances out. So the third quartile in this problem is data point number 38. If I had all 50 line up, the 38th biggest would be the one where the third quartile falls. So I have 13 data points right here. These guys are my 13 smallest because they're the lowest value on my picture. Then I've got my next 8 right here. If I do 13 and 8, now I'm up to 21 people or days or whatever it is. And if I add these 15 on, that is 36. So the lowest 36 are right here. If I go here, I'm too high, I'm 43. So that means that the 38th person lives somewhere in this bar, which is between 30 and 40. Correct answer on this one is gonna be C. Next up, looking at this problem, this is really weird. I don't know why my little eraser thing keeps coming back. It's kind of sad. I got myself two box and whisker plots here, and I have to look at these and make factual statements about them. First of all, with box and whiskers, please be aware you are using the 5-number summary, which is minimum, Q1, median, Q3, maximum. The mean is not readily available from a box and whisker. You can look at like which way it's stretched and like talk about the mean versus the median, but a couple of these choices, D and E, mention the mean explicitly. This last one compares the mean to the median, so I could maybe do something with that. But D is just straight up wrong. It's talking about, oh yeah, the mean is such and such. So I guess I started talking about E. It's a weird order, but I'll address this one anyway. If you look at the female distribution, the median is right there. And the skew on this picture is a little bit odd. The whiskers are roughly the same size. This whisker on the left is a little longer than the one on the right. So if you're like, oh, the inside looks like it's stretched right, but the tail looks like it's stretched left, it's better to go by the tails. So this one is kind of ambiguous, honestly, in terms of direction of skew. I might say a very slight left skew, but it's not super evident from the picture. The mean does go towards the tail, the skew of the graph. So the mean would be probably a tiny little bit left of the median, which is what this choice says, but that's a little bit shaky. I think there's going to be a much clearer answer in the first couple. So let's get to those. So on letter A, they talk about 50% of males being between 170, which is here, and 178, which is there. Each section of a box and whisker is 25% of your data. So if this would have said 25 on A, that would be a correct answer, but it's not. B says about 25% of the male students are taller than the tallest female students. Well, there's my tallest female student right here at the edge of this box and whisker. That lines up perfectly with this chunk of the male graph, which is 25% of the data. So this is the correct answer on this one. It's going to be B because the top 25% are taller than the female. All right, choice C says the median for males is 163. They meant females. That one is wrong. So, last multiple choice question. On this multiple choice question here, we are looking at the mean versus the median, which is a good thing to talk about with respect to resistance measures of center and how they're affected by outliers, et cetera, et cetera. The mean. So this is good to remember right here. Remember earlier in class, we talked about how if you have a distribution, the mean is what makes it balanced. So if like one side is heavier, then the mean is going to have to adjust to make sure it doesn't like tip over. Okay. So if you picture like where would I put my finger underneath that graph, that's a rough guess of where the mean is. The median is the equal area point. So if you chopped it up and found the geometry area of both sides, it would be the same. So for this picture, neither of those things is going to be at tick mark 1. That is just way too far over. That's not a mean or a median. You wouldn't be able to balance way over here, and you also wouldn't have equal area. So any choice mentioning 1, I'm going to go ahead and toss out right away. So 2 and 3 are my options, and the mean is not resistance to outliers. So the mean gets pulled towards the outliers or the tail of the graph. The median is going to be on the other side of that. So my outliers, not really outliers, but my more extreme values are here on the low side. The mean is going to get pulled that way. So the mean goes towards the tail. The median would be to the right. So 2 must be the mean, and 3 is the median. That is choice E. So that wraps up our multiple choice section, and let's go on and talk now about our free response section. So the question on this free response section was actually a question on the 2019 exam. I know I used it this year, so 2020 kids, this was on your chapter 1 test back in the day. I probably used it again in 2021, 2022, I don't know. It's a good question. I like it. So you might have seen this question before already, but that's okay. It'll make good review. So they ask you to write a few sentences describing the distribution of room size. That is SOX, shape, outliers, center, spread, in context. I'm pretty sure they'll do something with this on your exam. If not this year, then certainly in the future for my other kids. Do make sure you can do these problems well. They're not the most fun questions to write out, but they're easy points as long as you hit all the things you need to. So in terms of socks, I would talk about shape first. That distribution, best word bar none, is bimodal. I have two peaks, one between 150 and 200, one between 250 and 300. The distribution of room sizes at this dorm appears to be bimodal, with two peaks in square footage between 150 and 200 and 250 to 300. Shape, done. I said there are two peaks. I also gave a rough idea of where those peaks are located. Next up is outliers. There do not appear to be any outliers. There are no points like far off by themselves. It's hard to tell with a histogram sometimes. You just kind of use common sense. If this was a box plot, we could do the little dots on the picture on the edges. I'll just say there do not appear to be any outliers in room size. Center. So the rough center, they don't need you to be super accurate with this. Like you don't have to sit there and calculate what the exact mean or median or whatever is. I'm just going to say the center or the median room size appears to be, and using soft language like appears to be or is about is really good with stuff like this, appears to be somewhere around 200 to 250 square feet. Okay, give an approximate center and give an actual number for it. And then finally, I have to talk about spread. So room sizes vary from about 100 to 350 square feet. Socks, that would be a good full credit answer. Make sure you have context. I did it several times in there, but sometimes I read answers and they just talk about, oh yeah, it's skewed left and it's this and it's that. Definitely talk about context for it. So part B has two parts. It gives you this little table of stuff right here. And then it also asks you to check. So you have to check if there are outliers or not. And you have to graph it as a box and whisker. So I gave you a link to a URL to make a box and whisker because like trying to do this like I am here by writing on the page isn't going to work out very well. So you can get a picture from wherever, just take an image of something you made by hand and slap it in the document. That's totally fine. Before I get there though, the rule for outliers is 1.5 times your IQR. So 1.5 times IQR. IQR is going to be Q3 minus Q1. So I need to do Q3 minus Q1. That's not a Q. Kind of awkward typing these out. I wish I could have a faster way of doing this, but such is life. So I'm going to do 292 minus 174, and that equals 118. So that's my IQR, is 118. Interquartile range, Q3 minus Q1. I'm going to take my 118, and I'm going to multiply by 1.5. If you do that, I got 177. So what does that number mean? This part usually kids are cool on, but the next part they do mess up. That is how far you are allowed to be from your box before you're an outlier. So from the box means from Q1 and smaller, or hope this is smaller when you guys look at this and it's not reversed, Q3 and bigger. So actually I can show you with my picture. That'll be clearer than me just gesturing here. If this is my Q3, I can go 177 that way and be okay and not be an outlier. If I am at Q1, I can go 177 this way and not be an outlier. Outliers show up as dots on the box and whisker, so my spoiler right here is that there won't be any outliers. But let's talk actual calculations for how you do that. So with this problem here, I need to do my Q1, which is, let's see. So Q1 is 174. I do 174 and I take away my 1.5 times IQR. That's a negative 3. And I take Q3 and I add 177. And that's going to be 469. If you are between negative 3 and 469, you're not an outlier. Every single data point is in that range, and I know that because my min is 134 and my max is 315. So since all values in the data sets are between -3 and 469, there are no outliers. Showing your work on a problem like this is very key. Make sure you write down your little calculations or type them up. Second part of this question was to make a box and whisker, which I have right here. You have min, Q1, Q2 median, Q3, and maximum, and you just draw them. Outliers get dots. If you have an outlier, the whisker goes to the biggest number or the smallest number. That's not an outlier. So it goes to the next largest number that fits in the range. All right, last question. Now, true story here. I like to do the AP questions myself, write them up before they actually release the answers, just to see like how I would do and to make sure, like I'm curious and I want to know what the questions are about before they actually tell us at the end of the summer what the solutions are. I actually lost credit on this problem last year because I read this problem too fast and I did it backwards. So be careful with wording on these questions that you don't answer the wrong thing. They say, what characteristic is apparent from the histogram but not the box plots? I did box plot, not histogram, and I talked about a little bit of skew to the data, like it's skewed left, which is a fair statement, but it's not what the question asked. They want to know what you can see in the histogram up here that you cannot see in the box plots. And the correct answer to that is going to be the bimodal nature of the data sets. So in the histogram, it is evident that room size follows an approximate bimodal distribution, but it is not possible to see this in the box plots. You could add a little more fancy vocab. Don't give too short of answers when you do this. But I believe that is the big thing they're looking for in this question. So that is our Chapter 1 study guide. You guys got one more question. It's a real good one about catapults that I sometimes use on tests. And get that answered and share your doc with me. Thank you, guys.